Hello, in this video, let us learn some important concepts of 8086 programming by using multiple choice questions. Question 1. If DS is 2000 H, that means 2000 hexadecimal, AX is 000 H, BX is 1000 H, CX is 2000 H, then this is the memory location 20,000 H contains AAH, and the memory location 21,000 H has byte BB. The memory location 22,000 H has the value CCH. After execution of 8086 translate instruction, XLAT is translate instruction, the contents of register AL would be any one of these. Now we have to understand the instruction translate. This instruction will translate a byte in AL using the byte stored in the memory address DX:BX plus AL. So the base address is provided by this value, and from that it will go to this value and take a byte from the memory and it will put it in AL. So first we have to calculate DS:BX. So the data segment value is 2000, all are hexadecimal digits. Then BX value is 1000. So we may not simply add these two to get the effective address. So you will add 10 here and you will put 100, all are hexadecimal digits. This is code segment and this is BX. So the effective address is, add these two in this way, 0, 0, 0, 1, this is 2. So it points the memory location 21,000 H. And according to the instruction, AL value should be added. Here, AX value is 000 like this. Yeah, this is AL and this value is AH. But we need only AL. So with this one, you have to add AL, that is 00H. So you will get only 21,000 H. This is the address required. From this address, a byte will be taken and that will be put into AL. So in 21,000 H, we have BB. So finally, AL will contain only BB. So the correct answer is BB. Now let us see question 2. What will be the contents of AL after execution of the following instructions? Move AL, 39H. So 39 will be moved to AL. Similarly, move BL 35H. So 35 will be moved to BL. 39 will move to AL. Now add AL, BL. So AL has 39 and BL has 35. Now you add these two, 9 plus 5, 14. That means E. This is 6. So after adding these two, you will get 6EH. Now this instruction is ASCII adjust accumulator. So this instruction is ASCII adjust accumulator. So in AL, you have 6E now. When this instruction is executed, AAA, then 6 will be added here. So E plus 6, 14 plus 6, 20. That means 1, 4. So that 4 will come here. 20 in hexadecimal, it is 1, 4. So 4 will come here. And that 1 will be setting the carry flag, and the 6 will not be used. So you will have 4 in the AL, and in the carry flag you will have 1. But anyway, the answer is 14, but the second digit will be available only in the carry flag. So the AL will contain only 04. So the correct answer is 04. Now let us see question 3. What is the EBCDIC code corresponds to decimal 9? We know that in the case of ASCII, a number 1 will be indicated by 31H. Just 3 will be added in the second digit. 2 will be represented by 32H. So like that, up to 9 you can have up to 39. But in the case of EBCDIC code for decimal number 9, you will just add F before that. So the code for 9 in EBCDIC form is F9. So this is correct. Now let us see question 4. If AL is equal to 35, BL is equal to 39, and carry flag is set, after the execution of the instruction add with the carry AL, BL, the contents of AL will be AL contains 35H, BL contains 39H. Both will be added. 5 plus 9 is 14. 14 means E. Then this is 6. And carry flag is 1. It is set to 1. So you have to add that one also here. So E plus 1 is F, and this is 6. So the correct answer is 6F. Let us see question 5. If DL is equal to EEH and carry flag is reset, actually reset means carry flag is 0, what will be the contents of DL after the execution of the instruction rotate left without carry DL, 0, 1. So the contents of DL will be rotated left side by 1 bit. DL contains EE. So you put it in binary form. E means 8 plus 4, 12. This is E. 8 plus 4, 12 plus 2, 14. E is 14. So here also 1, 1, 0. Now carry flag will be here. When you rotate left, this will come here. So the first one will be 1, and the 0 will come here, and this 1 will come here, this one will come here, and this one will come here, this 0 will come here, and this one will come here, and this one will come here. This is 8 plus 4, 12, 13. 13 means D. This is also D. So after rotating left, the AL register will have DDH. Question 6. If AL is FFH, after the execution of negate AL, the contents of AL would be, actually this instruction is negate. Negate will take 2's complement of AL. So AL contains FF, that means 1, 1, 1, 1, 1, 1. This is F, this is F. So take 2's complement for this number. It will be 0, 0, 0, 0, 0, 0, 0, 0. Now this is 1's complement. For taking 2's complement, you will add 1. So you will get 0, 0, 0, 0, 0, 0, 0, 1. So the answer will be 0, 1. Question 7. Which of the following instruction is equivalent to exclusive OR AL, AL? See, in the case of exclusive OR, if 2 bits are different, then only the result will be 1. If both are same, result will be 0. whatever may be the value you are having in AL, if the same value is exclusive odd, then the result will be 0. If both are different, the bit will be 1. If both the bits are same, then the result will be 0. So when you do this operation, AL will contain only 00H in hexadecimal form. Now you take this instruction RAL00. R operation means if any one is 1, output will be 1. So it will not make the AL register value 0. If you AND any bit with 0, then the result will be 0. Because in the case of AND operation, if both are 1, then output will be 1. One bit is 0, then the output will be 0 irrespective of this first bit. So this will produce a 0 in AL. For other operations, you will not get 0 in accumulator. Question 8. What will be the contents of AX after the execution of the following instructions? Move AL FF. So AL has FF. Then BL has 03. Multiply BL. When you execute this instruction, AL will be multiplied with BL and the result will be stored in AX. Now multiply this, convert this hexadecimal to binary 111, here also 111 and into 311. So multiply this 1 into all this 1, 1, 1, 1, 1, 1, 1, 1, 1. Similarly, if you multiply this one, you put 1 here, you will have ones like this. Now you add, this is 1, 0, 1 plus 1, 0, there will be a carry. So carry plus 2, 3, 3 means you will have 1 and again carry. So that carry will be added here. Again you will have 1. Then you will have carry that will be added here. Again 1, 1, 1. Here also you will have a carry. So 1 plus 1 plus 1, 3. You will have 1 here. That carry will be added here. So 1 plus 1, 2. That means 0, 1. So this is the result. So the first 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. These 8 bits will be stored in AL and these bits will be stored in AH. So this will be in AL. So in AH you will have 0, 2. In all options 0, 2 is there. But in AL you have, that is 1, 1, 1, 1, these 4 ones, then 1, 1, 0, 1. So this will be F and this will be 8 plus 4, 12 plus 1, D. 13 is D. So FD is the correct answer.